Hello everyone. This is our group amortized conditions and the data structure we were given were Bloom filters. And our group members are Fatma Nasser, Sahil Suresh, Hamad, and Asari. So let's dive into what is Bloom filters. Although the name looks fancy, but it is a very trivial data structure. Basically, Bloom filter uses two things: a fixed size array, which is a bit array which stores ones or zeros, and it uses multiple or a single hash function so that it can hash a data and just put if it's put the consequent one in the hashed value. So let's see what it really does. So basically, when we take a data, it hashes the data and puts the one in the place of the hash value. For example, if you get a 10, and so at the 10th bit of the array will get a. So what um, what are the things that come up when they use false and you use Bloom filters? So basically, the first thing that comes up is false positives. Bloom filters sometimes gives us positives, which mean that a data is not present in the in the data set, but it says it is present. So to tackle that, we can use multiple hash functions or a bigger size fixed array. And to minimize that false positive probability, we have used this formula, which basically takes in the hash functions, this array size, and the number of keys. So why do we use Bloom filters? Bloom filters makes data retrieval easier because it takes the the probability of getting a false positive is very low, and it returns the query in O of k times. So now Fatma will tell you about the implementation.
I would like to call Gulzar to explain the interface for our Bloomfield implementation.
Okay, for the interface part, we have used Tkinter library of Python, and we just import that. And then for images, we import Fill, and we have this bloom.py file in our folder, in which we have a function which is book details, which will return everything we need when will it call. So यहाँ पे we have used some background image and then image for logo. फिर यहाँ पे एक एंट्री बॉक्स है जहाँ पे हम बुक का टाइटल एंटर करेंगे और एक बटन उसके राइट साइड पे एक बटन होगा। जब हम उसको क्लिक करेंगे तो उस हिसाब से उसका रिजल्ट जो होगा वो दो आउटपुट बॉक्सेस बनाए हमने, उसके अंदर उसका वो डिस्प्ले होगा। एक आउटपुट बॉक्स तो उसके लिए बुक की डिटेल्स, टाइटल, ऑथर, रेटिंग्स वगैरह के लिए, और एक आउटपुट बॉक्स उसकी जो भी बुक हम एंटर करेंगे उसके अगर वो हमारे डेटा सेट के अंदर है तो सिमिलर बुक्स उसके जॉनरा के मुताबिक सिमिलर बुक भी डिस्प्ले होंगे। और यहाँ पे जो हमारा बटन है, बटन में हमने ये कमांड दिया हुआ है कि जब हम बटन के अंदर कोई टाइटल बुक का टाइटल हम लिखें और फिर जब हम सर्च हिट करें तो कमांड ये है कि वो सर्च बुक का जो फंक्शन है हमारा टॉप पे, फातिमा अगर वो सर्च बुक का वो फंक्शन दिखा दो। तो सर्च बुक का जो ये फंक्शन है, तो इसमें एक्चुअली हम बुक गेट कर रहे हैं, उसका टाइटल गेट कर रहे हैं जो हमारे एंट्री बॉक्स के अंदर होगा, वो क्वेरी के फॉर्म में यहाँ पे आ जाएगा। और वो क्वेरी जो होगा वो बुक डिटेल जो फंक्शन हमारे bloom.py के अंदर है उसके अंदर जाके कॉल होगा, और फिर वहां से एक लिस्ट रिटर्न होगा जिसके फर्स्ट इंडेक्स पे हमारे बुक के डिटेल्स होंगे और सेकंड इंडेक्स पे सिमिलर बुक्स होंगी। अगर वो क्वेरी डेटा सेट के अंदर है, वो बुक हमारे डेटा सेट के अंदर है, तो वो रिटर्न करेगा फर्स्ट इंडेक्स पे बुक की डिटेल्स, और फिर सेकंड इंडेक्स पे उसके होगा उसकी सिमिलर बुक्स जॉनरा के मुताबिक। तो यही था इंटरफेस हमारा।
So this is the interface Gulzar was talking about and explaining. Thank you, Gulzar. I would like to explain now the implementation of the Bloom filter that we have done in this file. So over here, we are using two libraries of Python, that is MMH3 and math. One is for for using hash functions, and another is for implementing a small formula that will help us in defining the appropriate size for a bit array. We have two files that we are using that contain our data, which is books data and data.txt. Books data contains the title, whereas data contains the information about these books. We use list to store the data from these files so that we can do our query on them. And we split the data list into a nested list because it contains three parts of information about the book, that is the author, the rating, and the genre. And these are used so that they can be, then the book can have a recommendation system where we can recommend same genre books to the user. So the bit array is a function that is designed to help us determine the appropriate size of the array for the Bloom filter, or have an appropriate size that can have bits set to 1. So we use this function using our math library to give us near to ideal length of bit array so that we have very few false positives. Over here we have function add that takes in data and then converts the data into two different indexes for our bit array. Then we take these indexes and set them both to 1 and return our updated bit array. For this function, we are checking whether a certain data set is present in the bit array or not. So when we take in the data as our parameter and we create two indexes, again using the same hash functions that we used before, we will get two indexes. To make sure that our data is in fact in the bit array, both index 1 and index 2 should contain the value 1. It cannot be one or the other, or it cannot be 0 for both. If only one has the value 1, then the data point is not in our array. So this function is if we extract data if we have the object in our bit array. We have the book, the author, the ratings, and the genre, and then we use this to output in our interface and return similar books to, to the one that we have and recommend them to the user. So running the file, if we search for a book to see if the user has read it or not, we can check the details of the book and whether we have read it or not. And then it suggests us a similar book. We will check if we have read that book or not. So we have not read this book. That is our project, and thank you for listening to our presentation.